Chemistry, this is the answers video for the day 1819 assignment. It was originally due on Tuesday. I'm going to make it due on Thursday, September the 29th. And let's go ahead and get started. The first page is an explanation for you to read as you see fit of this relationship between weight of substance and how many molecules or atoms or big bundles that we call moles it has. That's the only way we can do chemistry, is to be able to weigh things, and by the weight of a pure substance, either an element or compound, we can find out how many particles it has. Okay, so that's what this whole assignment is about, and you can just read that as you see fit. Let's go ahead and go with the problems now. I'm not going to do every problem, but I'll do a pretty fair number of them, and you do the rest. Okay, so for each of the following equations, do the following so you know what's going on here. We've been doing this. So we have two parts. We have what the chemical equation understands, which is numbers of particles. It's taking one molecule of C2H4 and matching it up with 3 of O2. Or these big bundles, which taking 1 mole of C2H4, 6.022 times 10 to the 23rd, and matching up with 3 moles, 3 times 6.022 times 10 to the 23rd. Or as we say, we really think of these as relationships or ratios now. Whatever number of C2H4 we have, it could be any number of moles, we got to have 3 times that many moles of O2. So this is where you would put those numbers. Now we can't count moles, we can't deal with moles, we can't see molecules, so we deal in grams. So the number of grams that the question gives you goes down here. And then you need the translator to get you between grams to moles, moles back to grams. And so we need to fill these in. So I'm going to do that quickly, but this is a skill you should know how to do. So C2 is 2 times 12.01. H4 is 4 times 1.01. If you multiply those out and add them together, you get 28.06. O2 is 32. 2 times 16 from your periodic table. CO2 is 12.01 plus 2 times 16 is 32, and you add that, the 12.01 plus 32 gives you 44.01 grams for 1 mole of CO2, and H2O is 18.02. Okay, so now we're ready to get started on this. So follow the steps. Okay, the steps are always the same on these. All right, so how many moles of CO2 will be produced from 4.2 moles of C2H4? So you always start off, what are we looking for? Where are you trying to go? So you want it over here, you're trying to find how many moles of CO2. And what we're given is 4.2 moles of C2H4, so we come way over here. We don't know how much space we're going to need, so we're going to put it way over here. Okay, so we're going to fill in our graphic organizer lightly. Do this with pencil and do it very lightly because you're going to erase it for every problem. So the question mark for us is moles of CO2. That's what we're trying to find. So this is the moles row. There's CO2 right there, so it's a light question mark right there. 4.2 moles of C2H4. Again, moles row, but we're under C2H4, so 4.2. Okay, so we only have to go in one direction. We only need one arrow. So we're going from here to here. That's a single conversion. Moles to moles is a single conversion. So times, I'm going to draw the box. I just think it's helpful at first to make it visual. And the equivalency simply comes straight out of the chemical equation. 1 mole C2H4, you could just add the word mole below each coefficient here. You just kind of squeeze it in there. 3 moles O2. 2 moles CO2, 2 moles H2O. Again, it's in the moles row, so that tells you they're all moles anyway. So 1 mole C2H4 equals 2 moles CO2. So for every 1 mole of C2H4 you put in, you're going to get 2 moles of carbon dioxide out. So that's called the equivalency. Now we have to put one over the other. Which is it? We need moles of C2H4 to cancel and moles of CO2 to appear on the top. So we're going to put the 2 moles of CO2 up here and the 1 mole of C2H4 on the bottom. Moles of C2H4 cancels and cancels. Last man standing is moles of CO2. So the answer is 4.2 times 2 divided by 1, and that equals 8.4. So the equation tells us we're going to get twice as many moles of CO2 as we put in moles of C2H4, and that's what we did. 8.4 is twice 4.2. All right, we'll keep moving on here. So first thing you want to do is erase the 4.2 and the question mark, because you're going to reuse the graphic organizer. Again, that's to help you visualize the flow of the problem. Okay, how many grams of water will be produced when 6.4 moles of C2H4 are consumed? So we're trying to find grams of water. So we come way over here, equals, underline, that's where our answer goes, and it's G, and water is H2O. And we're starting with 6.4 moles of C2H4. Start way over on the left. You don't know how many conversions you're going to need right away, so just go ahead and put it way over here. Okay, and we come up here, and the question mark is in grams of H2O, so you're in the grams row underneath H2O. So it's where this and this come together. It's right there, grams of H2O. Okay, and then we have moles of C2H4. So moles row and C2H4 right here. So 6.4 is there. So we need to start here and get to here. So how do we do it? Well, remember the rule, you could only go sideways inside the chemical equation. You cannot go sideways down here. So we're going to jump from this box over to this box, moles of C2H4 to moles of H2O. And then we're going to go from moles of H2O to grams of H2O. So the conversion to get from these two boxes, the first conversion, is simply what the chemical equation says. 1 mole C2H4 equals 2 moles of H2O. And then to get from moles of H2O to grams of H2O, anytime you're going up and down, you're using the molar mass. In this case, it's for water. Okay? So let's go ahead, and I need 2 conversions. So I'm going to draw 2 boxes. And I'm going to write the 2 equivalencies that I just said, this to this. So which one goes on top, which one goes on bottom? We need this to cancel out. So this one, it goes on the bottom. The other one goes on the top. Moles of C2H4 cancels with moles of C2H4. Now our second conversion is the molar mass. Anytime you're going up and down, it's the molar mass. 1 mole of H2O, you have to write that, 18.02 grams of H2O. So we're going to write that down here. 2. Okay, those 2. Which one goes on top? Which one on bottom? You need moles of H2O to cancel out. So since it's up here, it needs to be down here. So we're going to put this down here. And on top goes the other one. Moles of H2O cancels and cancels. The last man standing is grams of H2O. You didn't cancel that. That has to match up with the units in your final answer. It does. Okay, so now what you do is you multiply everything on top, 6.4 times 2 times 18.02, and then you hit the divided by sign for everything on the bottom. Divided by 1, divided by 1. And the calculator shows 230.657. I'm just going to round that to 230.7. Again, I'm not going to worry about sig fig. But if I were, it's 2 sig fig because this only has 2 significant figures. Remember, moles relationships like this are out of the chemical equation. They're not measured values. So they don't limit your significant figures. This is a measured value, something you measured in the lab or elsewhere. This is a measured value. So they limit your sig fig. So this would actually be, it would actually round up to 231. 230 because it can only have 2 sig fig. Anyway, we're not going to worry about that at all. Okay, I'll mention it, but don't worry about it. I'll move on to the next problem. Okay, so how many grams of CO2 will be produced by 3.7 moles of C2H4? So it's a similar problem. Okay, so we need to get grams of CO2. So grams row underneath CO2, Right there, that's where they intersect. And it's 3.67 moles of C2H4 right here, 3.67. So we need to start here and end up here. So you got to go sideways here. So there's your conversion. 1 C2H4, 2 CO2, and then to get out to the question mark, you have to use the molar mass for carbon dioxide. That's a 2 conversion problem. So let's go ahead. Okay, so now we're going to come over here. We're looking for some number of grams of CO2. We're starting off with this. We're going to put it way over on the left. And we said it's a 2 conversion problem. I actually didn't give myself very much room here. I should have given myself more space. Always put this way over on the left and this way over on the right. Okay, so the first one is we need to get from moles of C2H4 to moles of CO2. It's 1-to-2 relationship, so you just copy that out of the chemical equation. Okay, which one on top, which one on bottom? You need moles of C2H4 to cancel out, so that means you need it down on the bottom here. Cancel and cancel, and then the other one, 2 moles of CO2 on the top. Okay, now we need to get out. We're now sitting in this box right here. We need to get out to our question mark, so it's the molar mass conversion is our equivalency. Okay, which one on top, which one on bottom? We need moles of CO2 to cancel out. We need grams of CO2 to appear on the top for our final answer. So we're going to put the 44.01 on the top. Moles of CO2 cancel. Grams of CO2 is our last man standing. So it's 3.67 times 2 times 44.01 divided by 1 divided by 1. And that's going to give us 323.0. I'm just gonna go to one place after the decimal generally. Sig fig, it's limited to 3, so it actually should be 323 without the decimal point 0, and that would be 3 sig fig. Okay, I want to go to a grams to grams. So we're going to jump down to H. Down here, the rest of them are grams to moles, moles to grams. I may go back and do one of those. Let's do one that goes the other way. I will do F first, okay? So how many moles of O2? So right away, again, try to wean yourself, get off of using the graphic organizer, but use it as you need it. So it's asking moles of O2. Okay, are required to make 12.52 grams of H2O. So put that way over here. Leave yourself a lot of space for the boxes. You may not be sure how many you need. Okay, so there we are. So now we're going to come back here. Moles of O2, grams of H2O. So we're going to erase everything up here. And it's moles of O2, moles row underneath O2. That's the question mark. And it is 12.52 grams of H2O. So you come down to the grams row that we can measure on a scale, and H2O, and it's 12.52. Okay, so we need to get from 12.52 to this question mark, so you have to go up and then over. So up is through the molar mass conversion, and over simply relates 3 moles O2 equals 2 moles of H2O. All right? Hopefully this is starting to look very repetitive. All right? So it's 2 boxes, 2 conversions. Okay, so there's the molar mass for water. One of these on top, one on bottom. You need grams of H2O to cancel out. That means it has to be the one on the bottom. And the other one is on top. Grams of H2O, grams of H2O. Okay, so you're done with that. So right now you've moved up through this to there. So now you're sitting in this box. You need to get over between these two. 3 moles of O2 equals 2 moles of H2O. That's your next equivalency. Okay. Okay, so which one on top, which one on bottom? You need moles of H2O to cancel out, so this one goes on the bottom. So moles of H2O cancels with moles of H2O. Moles of O2 is the last man standing. It matches up with our answer. That means we set the problem up correctly. So now you go ahead and do the math. Okay, so it's 12.52 times 1 times 3, everything on top, and then divided by 18.02, divided by 2, you hit equals, and you get 1.04. That's a 4. 1.04 moles of O2. Okay, now I'm going to move down and do H. Now this is a grams to grams. That's the most involved one. It's not any harder. It's just 3 steps. Okay, you're going to see that in a sec. So we're trying to find grams of O2. So way over here, and you're going to use the entire width of the page on this one. That's what we're trying to find. We're starting with 12.6 grams H2O. We're going to go way over to this side because you're going to need 3 conversions. If you're not sure of that, I'll show you in a second. 12.6 grams of H2O. So grams of H2O to grams of O. Grams down here of H2O, and you want grams of O2 is what you're trying to find, so your question mark is there. So you need to start here. You need to go up into the equation using the molar mass of water, then side to side using this relationship between moles of O2 and moles of H2O. That gets you to here, and then you come back out to the question mark using the molar mass of O2. All right, so let's go ahead and set that up. And it's 3 boxes. Okay, so the first one is this one. We're going from 12.06 up here using the molar mass of water. So write that down. And I'd start way over on this side to do that. Okay, all right, off screen a little. So there you have it. Which one goes on top and bottom? You need this to cancel out, so it has to go on the bottom. So it's the 18.02 grams. And the other is on the top. Okay, grams of H2O, grams of H2O. Okay, so now we're sitting in this box right here, and we need to get from here over to here. So the relationship is in the equation. 3 moles O2 equals 2 moles H2O. Okay, which one on top, which one on bottom? You have moles of H2O up here. It needs to cancel out. So it's the moles of H2O goes on the bottom. And the other one, 3 moles of O2 on the top. Moles of H2O cancels there and there. Now, finally, we're sitting in this box, and we need to come out, and we use the molar mass of oxygen. Okay, which one on top, which one on bottom? You need moles of O2 to cancel out, so moles of O2 has to go on the bottom. Cancel, cancel. The other one's on top. Last man standing is grams of O2, which is what's in our final answer, so we know we did that correctly. I'll do this calculation on screen for you. So here we are. Try to get it so you can see everything. Okay, so it's 12.6 times 1 times 3 times 32, everything on the top. Now you divide it by everything on the bottom, 18.02 divided by 2 divided by 1, and that all equals 33.6. And that's right there. Okay, there we go. So we've done one of each type of conversion that we need to do. Is there anything else? Moles to grams, we've done that several times. Moles to grams, we've done that several times. Grams to grams, we just did one of those. I'll leave that for you, and there's another grams to grams. I'll do the second one, and then we'll be finished with this problem. Moles to moles is easy. Maybe you forgot how to do it. Maybe I'll do that one too. Okay, let's go ahead and do this. Let's see. I'm going to see how quickly I can do this one. Okay, just to show you, these don't have to take forever. So here we are, grams of CO2 equals, that's our final answer. So that's what you're trying to find. We're going to start with 5.7 way over on the left. Start with 5.7 grams of O2, end with grams of CO2. So I'm going to come back here. Get all these. Okay. So here we go. So 5.7 grams of O2. Here's O2. Here's the grams row. So that's 5.7. And we want to end up with grams of CO2. That's the question mark right there. Grams row under CO2. So you need to go up through the molar mass to the right using the relationship between these two, and then back down using the molar mass of CO2. All right, so let's go ahead and do that. So I know I'm going from grams of O2, and I've done enough of these problems that I know grams to moles, so we're going up. So of O2 equals 1 mole of O2. And I didn't draw my boxes, so let me do that. The boxes will soon be optional. I just want you to do it at first to visualize the number of conversions. Okay, so here we go. Okay, so I have 5.7. I'm going up, and I have to have my molar mass. I'm using a different sheet here just because it's a little cleaner. And this 1 mole is 32 grams of O2, not of 1O, but of O2. So I come up through this. That's my first conversion. Which one on top, which one on bottom? It's going to be grams of O2 on the bottom because it needs to cancel, so it's going to be 32. This one goes on top. Cancel grams of O2, grams of O2. Okay, now I'm sitting in this box right here. I need to go from here to here. That's these two. 3 moles of O2 equals 2 moles of CO2. Okay, which one on top? You need moles of O2 up here to cancel out down there. And the other one goes on top. Moles of O2 cancels. Okay, so now we're in this box right here. We need to get out to our question mark. I need the molar mass, which I wrote on the other sheet, 44.01 grams of CO2 equals 1 mole. So I'm going to write that conversion here. Okay, which one on top, which one on bottom? I need moles of CO2 to cancel out. So that means this one's going to go on the bottom. And that puts the other one on top. Moles of CO2 cancels and cancels. Grams of CO2 is the last man standing right there. So we multiply 5.7 times 1 times 2 times 44.01, divide by everything on the bottom. Divided by 32, divided by 3, divided by 1. Okay, and that gives us 5.2. All right. Okay, what else do you have to do? I think that's all I'm going to do for this problem. We did every one of them in class. Okay, this one's asking you to compute molar masses first, to fill in your molar masses. Well, O2 is 32. You've seen that before. CO2 is 44.01. 12.01 plus 32 gives you that. And H2O is 18.02. So again, this is going to be on the first midterm, and so it's going to be C, you have 3 of those, times 12.01. H, you have 8 of those, times 1.01. And that gives you 44.11 grams per mole. So that's what goes up here. Okay, so that's how you would do that. Okay, and I want to see what else we got. And you know what? You know how to do every type of problem that you have to do. The rest of them are on you. Now, since it took me a while to get this up, this will be due on Thursday. Okay, so you can change this Tuesday, September 27th to Thursday. September 29th. Okay? And that'll take care of the answers for this lesson.